One-to-one functions. Let's start with the formal definition of a function f is said to be one-to-one whenever x1 and x2 are in the domain of f and f of x1 equals f of x2. Then x1 must be equal to x2. Essentially, you could also say if x1 and x2 are distinct points, not equal, then that means that f of x1 must not equal to f of x2. Let's take a look at what this means on a graph and then put it into everyday normal language. Let's look at the 2 points that I marked and find some ordered pairs. So as an ordered pair, we see that this has an x input of 3 and it's associated with the y of 3. And in function notation, remember, we could write things like this. So here our function is taking an input of 3 and it's spitting out a y, or an output of 3. Let's do that for this point on the other side. So as an ordered pair, we see our x is 4 and the output is 3. So in function notation, our function is taking in an input of 4 and it's giving us a 3 as the result. Now let's use this definition of a one-to-one function to see whether or not we could say that this function represented by this graph is one-to-one or not. So let's look at the premise. The premise is that x1 and x2 are distinct points, or they're not equal. Let's go ahead and call our first point x1, y1, or this is the same thing as f of x1. And our second point we could say is x2, or f of x2. Okay, so x1 was 3 and x2 was -4. So the first part of our little qualification here is true. x1 is not equal to x2. Then, for this to be 1 and 1, we have to have that the functions are not equal at these two separate inputs. So f of x1 was 3, and we're hoping that is not equal to f of x2, or -4. But f of 3 we found here was 3, and f of 4 we found over here, and that was also 3. They were equal. So that means that this is not true, and this is not a one-to-one function. So now let's unpack and see what that actually means in normal language. All it means is that no two x's can have the same y. So here we had two different x's, x1 and x2, but they both had the same y of 3. So that's all that a one-to-one function is saying, is that no two x's can have the same y, and this is a function. So if we look back to the definition of a function, each element from the domain corresponds to exactly one element in the range, meaning basically that no two y's can have the same x. So a one-to-one function is just saying that every x only has one y, and every y only has one x. Hence the name one-to-one, one x for every y. We could look at it using an image like this, and we kind of say that elements in the domain, these x's, map to elements in the range. So if we have a one-to-one function, it makes a lot of sense that this x1 is only with this y2, and this y2 is only with this x1, nobody else. Maybe this x2 is with y1, and that y1 is only with that x2. x3 is only with maybe y3, and x4 would then have to be with y4. If it was with y2, that would violate a one-to-one function, because now we would have a y2 that was mapped to two elements into the domain. So here we see that in the mapping, there's just one element of the range for every element in the domain, and one element of the domain with every one element in the range.